Hello and welcome to this episode of Mrs. Mulvey's Math Movies. In this edition, we're going to talk about operations with complex numbers. First, we're going to do a little bit of a review to remind you what a complex number is. A complex number is just a value that has a real number part and an imaginary part. So, 2 plus 4i, there's the real part, there's the imaginary part, put them together, and you've got a complex number. So we talk about operations with complex numbers. We're just talking about adding them, subtracting them, multiplying them, or dividing them. And actually, this is a pretty easy process. Few key ideas you need to remember. You need to remember that I squared equals negative 1. Going back a little bit, I is the square root of negative 1. I squared equals negative 1. I'm just going to put this up here just for the reminder. I cubed is negative I, and I to the fourth is positive 1. So if I have two complex numbers, like 2 plus 3i and 4 plus 7i, and I want to add them up, adding and subtracting complex numbers is as simple as adding and subtracting the real number part and then the imaginary part. So let's take a look. If I'm going to add 2 plus 3i, that complex number, and 4 plus 7i, that complex number, you simply add the real parts. 2 plus 4 is 6. Add the imaginary parts. 3i plus 7i is 10i. And boom, I'm done. You get another complex number. So again, adding and subtracting complex numbers, really it's just like adding and subtracting any polynomial expression. You can treat the I mostly like any other variable. It comes into play a little bit different when we have multiplication in there, but adding and subtracting, just add the real parts, add the imaginary parts, and you're done. So let's look at one with subtraction. We're going to do 4 plus 3i minus 2 plus 2i. And so this time, instead of adding the real parts, I'm going to subtract them. I have 4, then I have the subtraction minus 2. 4 minus 2 is 2. Then I have 3i, then I have the subtraction again, minus 2i and 3i. In fact, I'll write it out over here. Minus 2i is 1i. And that's a positive, so I write that as plus I. So that's it. That's all there is to it. Where it becomes more complicated is when we start multiplying. So I'm going to erase what's up here. I'm going to put two complex numbers up here. And we're going to multiply them. So when you multiply complex numbers, you're going to use the FOIL system like you use when you multiply any binomials. And so I multiply, if I'm going to multiply these, I multiply the firsts. 3 times 2 gets me 6. I multiply the outsides. 3 times negative 5i is negative 15i. I multiply the insides. 2i times 2, and they're both positive, so that's positive 4i, and then I multiply the lasts. And I have 2i times negative 5i, that's negative or minus 10i squared. So very much like working with binomials with real numbers. The difference, though, is right here. Because you have the I squared can be replaced with negative 1. So instead of negative 10, excuse me, times I squared, we've got negative 10 times negative 1, and that becomes plus 10. So what I really have here is 6 minus 15i plus 14i plus 10. And then I can add the 6 and the 10, that's 16. I can add the negative 15 and the positive 14i, well I should say the negative 15i and the positive 14i, that gets me negative 1i. I don't really need the 1 there, so that just becomes 16 minus I, and that's the final answer. So what happens is this. As long as you have just an I and an I here, when you multiply the complex numbers, you're going to end up with a complex number. Notice two parts here. So let's look at another one. This time we're going to multiply. Oops, almost didn't use purple. We're going to multiply 5 minus 7i times negative 3 minus 2i. So again, just like before, multiply the firsts. 5 times negative 3, that's negative 15. Multiply the outsides. 5 times negative 2i, that's negative 10i. Multiply the insides. Negative 7i times negative 3, that's positive 21i. And multiply the lasts. Negative 7i times negative 2i, that's positive 14i squared. Remember, you're then replacing the I squared with negative 1. And so I have negative 15 minus 10i plus 21i minus 14. Because 14 times I squared equals 14 times negative 1, and that's negative 14. So now I have the negative 15 minus 14, that's negative 29. I have the negative 10i plus 2i, that's negative 8i. That's our final answer. The last thing we're going to talk about is dividing complex numbers. For example, if I want to divide 2 plus 3i by 4 minus 5i. This is the most complicated of the processes. You're actually going to use the conjugate. Remember, conjugate, same numbers, but opposite operation. And so you're multiplying by the conjugate of the denominator. And remember, you could write this 2 plus 3i divided by 4 minus 5i like this. So if you see it written like that, you just take it, put this in the numerator, put that in the denominator. So like I said, you multiply by the conjugate of the denominator. Clear up my screen there. And over itself, because I'm going to multiply by 1. Remember, multiplying by 1 does not change the value of what we have. And so I'm going to look at this and determine that the conjugate down here is 4 plus 5i. So same values, opposite operation. So when I do that, in the numerator, you have to multiply this using the technique we just learned. I'm going to multiply the firsts, 8. Outsides, that's plus 10i. Insides, plus 12i. Lasts, plus 15i squared. Replace the I squared with negative 1. So that would be 15 times negative 1, or minus 15. So I have 8 plus 10i plus 12i minus 15. That becomes 8 minus 15, that's negative 7, plus 22i. That's my numerator. In the denominator, when I multiply here and I FOIL it, what happens is I'm left with a real number. Because 4 times 4, the outsides get me 16. I'm sorry, yeah, the firsts. 4 times 4, those are the firsts, get me 16. Outsides here get me 20i. Insides get me negative 20i. And so my imaginary parts cancel out. 20i minus 20i is 0. My lasts become negative 25i squared. When I replace the I squared with negative 1, that negative 25i squared becomes negative 25 times negative 1, that's positive 25. And so what I end up with in the denominator is 16 plus 25 make this a little bit more neat. And so my denominator, 25 plus 16, 41, yep. And so there it is. Final answer is, and then you can separate this out for the real part of negative 7 over 41 plus the imaginary part of 22i over 41. So that's what you do. You multiply by the conjugate of the denominator. So let's look at one more. We're going to divide 2 plus I by 1 minus I. So I'm going to write that as 2 plus I over 1 minus I. I multiply by the conjugate of the denominator, so I multiply by 1 plus I in the numerator and the denominator. When I do that, firsts give me 2, outsides 2i, positive, insides 1i, positive, lasts I squared. Down here, firsts give me 1, outsides get me 1i, insides get me negative 1i, they cancel each other out, add up to be 0, lasts get me negative I squared. When I replace each I squared with negative 1, I have 2 plus 2i plus 1i minus 1, because I squared equals negative 1, and down here I have 1 minus negative 1 becomes 1 plus 1 or 2. So I add the 2 minus 1, that's 1. 2i plus I is 3i. Denominator is 2. And so there it is. And again, you can separate it out to have the 1/2. 2 goes to each one. So I have 1/2 plus 3/2 I, or 3i over 2. So that's it. I hope that helped you.